The second group can summarize the result of the activity.
Valentina here, hi. In our group, I think there is Gianluca who wants to show us something because the other people had some problems running Mappy. But Gianluca did a great job, so he can show and say his thoughts about the map. I just want you to know that I suggested them to move the linear features on top of the constructed map so they could find themselves with the geography, let's say. So, Gianluca, the stage is yours.
Okay, thank you very much. Yes, so I'm going to share my screen. I think it's this one. Okay, can you see my screen? The ArcG, the QGIS map. Can you see it?
Yes.
Yes, we can.
Okay, good. So yes, I use the Mappy to create the polygons from the spectral contacts that I drew in the attempt to create all the spectral units that we could see from the spectral raster. And of course, there was not much time, so I did my best. And I can say that it, I'm going to switch off for a moment the geomorphological map and also the linear feature. And just to show you that there is some, not very good, but there is some correspondence between the constructed map and the spectral raster. Then, of course, there are some points which I'd like to highlight of correspondence between the geomorphological units and the spectral units that, that I drew. So the first one that I'd like to highlight is the presence of the unit 4, the one in red, is mostly contained within the basin rim. And as far as I could see, it's quite lacking outside the basin rim, except to this in this area just south of the basin rim. And also there was a variety of units, of spectral units within the crater floor contained inside the inner ring, which include unit 5, spectral units 5, 9, 6, and 8, maybe even 10. So there was a large variety of units, also 6, also 4 actually, the yellow one. And in the same area, there are also geomorphologically a large number of grabens, which are these linearly shaped areas of crustal extension and surrounded by ridges. So, okay, apart from the inside the basin, impact basin, other areas of interest are, of course, the one colored, let's say colored in orange. I'm referring to unit 7, which are I have mapped in 3 different locations. The largest of them is the one at the northeast, which corresponds geomorphologically to a pit, which is this area surrounded by this scarp. And if I switch off the constructed map and also the geomorphological map, it corresponds to these large pits, which we also saw in the previous lesson, that define the faculae, the facula area. And most importantly, thanks to the spectral data, we can see that the material that was possibly erupted from these pits, which I'm assuming they might have had a volcanic origin and not an impact origin. We can see that it was spread well over the area defined by the crater itself, which is not the impact crater, but the rims of this pit. And similarly, I could identify some other similar locations just at west of this larger one. There's even here this geomorphologically, we can see this pit surrounded by the rim, and at south, just south of, oh no, actually inside the big impact basin. If I switch off the constructed map, we can see here the pit geomorphologically, and well, it's hard to see at this resolution, but it corresponds to this small area. And one last note worth of mention is the presence of Unit 9 spreading from south towards northwest, and which corresponds to the ejecta ray, which we also saw in a previous lesson. So probably identifies the ejecta material that was deposited from another impact that we cannot, of course, see in this map. So these are the main points of interest that I managed to, together with Valentina, we managed to collect during our discussion.
Thanks, Gianluca. That's a real great job.
Very proud of my students.
Yeah.
Very impressive. Very impressive
Yes.
indeed.
We have a new mapper. So, Jack, are you okay?
I can show you. I'll embarrass myself even more than I intended to now, because I'll show you how rubbish my map is compared with Gianluca's. Well, rubbish is not right. I was busy helping my group, you know, so I didn't get to spend. But I agree with Gianluca. We can see very clearly Nater facula in the northeast, and I also agree that Nider facula to the west is much smaller. So has anyone got any hypotheses about what could be going on here? Because if we compare the geomorphology, you know, these vents are, you know, approximately equivalent in size. So why is it that this volcanic vents deposit is much more spectrally magnificent than the other? Has anyone got any ideas? Speak up, be brave. Maybe someone from my group can speak up if they've got any ideas. If you don't speak up, I'm going to volunteer you. Kay, do you have any ideas? Did you have a look at this this area?
Probably the reason could be temporal order of the events.
So what do you mean by that?
Yeah, the very prominent red unit over here seems to be on top of everything. So it even seems to be on top of all the different geomorphologic units. So it seems as if an eruption or some event caused this bright layer of deposits. And the other thing here, maybe it was not so strong, or maybe some event happened that cleared all the material.
Okay, has anyone got any other ideas?
Sorry, I have to log off, guys. It's Valentina here.
Okay, it's okay, Valentina. We can take care of the rest. Your group has already done very well.
Okay, thank you.
Ciao Valentina.
Ciao Valentina.
Thank
ciao,
you.
Grazie.
Ciao, ciao. Grazie.
Ciao Vale. Ciao.
Yeah, so Kay's had a good idea about maybe this larger deposit is quite young. It is on top of everything, so it's reasonable to suggest that it's one of the youngest events in this area. Maybe that's why it's so bright and has its own characteristic spectral class. And maybe these smaller events, maybe they are older, and so they have lost some of their vibrancy, or maybe even the erupted material has a different composition. That's another idea, and maybe that's why they have different spectral characteristics. So there are a couple of reasons why this could be. Right, I'll turn off my map because it is not so good.
Maybe, sorry, just an idea. But maybe the two volcanic eruptive areas are correlated in some way, and the smaller one is just a smaller, like a side eruptive fissure. But I mean, I don't know the scale there in terms of meters, but yeah, it looks like maybe a few kilometers. I don't know.
I mean, that is an interesting idea, but what always confuses me about this area is that these two vents, they're not very different in size. I mean, this one here is about 30 or 40 kilometers across, and this one is a similar size. So I would imagine that the eruptions that formed them both were, you know, similar in their explosive power, and so they should have similar deposits, but this one is very much smaller. So I think there must be something else going on, but it's just an idea.
Right, yeah, I didn't see that the one on the right is so small. Didn't notice that.
But no, it's a good idea. Right, I think my group has done some talking. Do one of the other instructors want to? Peg, what about your group? How did you get on?
Do you mean on this specific topic or?
Just how did the group make any observations? Has maybe David has had to go. That's okay. What about your group, Matteo?
Yes, actually, I have two people that have done a quite complete map. I think that even the other, but I didn't have the chance to share their work. So I don't know if I think they were Renz and Kai. If they want to, one of them, we'll say, talk about the work they have done or summarize it.
Don't know what's left to say, but I'll share what I've done. You see my screen?
Yes, I do, definitely.
Okay. So this is my constructed map, and this is the already existing map. I thought was most interesting is like from the already existing map, like the bottom part's almost all yellow, and you only have this subdivision between the planes, so the inner crater planes and the ejecta material and impact materials. But once you have the spectra, you see a lot more colors. And what I think is interesting is that both the planes inside the crater and outside the crater are actually the kind of the same material, which could indicate that part of the impact melt has been transported out of the crater. Yeah, that's one interesting thing.
That's a really good observation. If you switch back to the geomorphic map, you can see that there are some small patches of the smooth plains colored in pink all around the southern rim of the crater. But if you go back to your spectral map that you did, your yellow spectral unit is even more widespread, but seems to overlap with the area that is smooth plains. So I think what's interesting is that those patches of smooth plains probably correspond closely with that yellow spectral class. What's that? Spectral unit 10, I think. And so the spectral units are showing you where there are areas where maybe there's even more impact melt, but it's just not easy to see in the in the base map. So I think here the spectral information is helping it, augment the geomorphology information. So that's a really good observation you've made there. And you said there was something else that you thought was interesting.
Yeah, so if we look at this area, so if you were there on Tuesday, we saw that there was some volcanic activity here, and I think it also becomes very clear from this, from the spectral map, because we also see the orange colors, which we also saw on the other volcanoes. And you can see that actually the inner crater planes are different colors here. So there are probably like different stages of rock creation inside the crater. So the initial impact melts, but also new melts probably coming from this volcano.
Absolutely, full marks. Very good. That's exactly the sorts of observations that we were hoping people would be able to make. So you're beginning to see the power of combining the spectral information with the geomorphic information, because as you said at the beginning, Renz, if you just take the geomorphology, it all looks the same. But if you consider the spectra, then you can begin to differentiate between impact melt and volcanic products. So that's really good. And I'm sure plenty of other people in the practical made the same observation as well. So that was a contribution from Matteo's group. Francesca, did someone from your group want to show?
Yes, we have Julia that will show the result of the activity of our group.
Yes. Okay, you can see?
Yep.
Okay, so my map is not as beautiful as all of yours, but whatever. We just started with the by drawing the spectral map, the spectral contacts, and here we can see different zone by different spectral data. And for example, this is the a crater ray, the crater ray of the another crater, I don't remember the name. And we can have the geomorphological map that we can see is not shown here. So very simply, we can say that we don't always have a correspondence of the spectral data with the geomorphological units, as all of you just said. And here we got the final geostratigraphic map. So we have to decide, we just got different kind of features and so interpretation. So we have to decide how many units to define based on the different characteristics that we are able to recognize. And that's it. For example, here I just evidence the smooth plains, intermediate plains that is visible in the geomorphological map. But here, okay, yes, I didn't yet finish, but whatever, we can see that there is not a clear correspondence with this map. It is not so visible, these smooth intermediate plains. So simply we just got different spectrum geomorphological data and analysis.
Great. So whenever I was making the map that you've got on your screen at the moment, I was sometimes a bit frustrated that there wasn't always a good correspondence between the spectral units and the geomorphic ones. But so that you said that sometimes the intermediate planes and the intercrater planes, they weren't so well characterized by spectral units. Can you guess why that might be, Julia?
Can you guess?
Can you guess or give an idea what you think the reason is why there are some geomorphic units that don't have a clear spectral signature of their own?
Well, actually, no, I don't know. I have to figure it out, all this new stuff for me.
Oh, that's okay.
Yes, it just maybe as you just said that we got, I don't know, we got different materials, smooth planes. Yeah.
Does anyone else in the group have an idea why some geomorphic units might not have a clear spectral signature?
Maybe I could.
Yes, go ahead.
It could be maybe that they are just simply created out of the same material, or that they are maybe not created during the impact, but erosion processes later. So it's just simply the same material, thus the same spectral properties.
Mm-hmm.
Okay, maybe I can say that maybe I'm just figuring out smooth planes may represent the high maturity terrain, maybe, I don't know. And so I've got, yes, and like I just said, the same material because it's high maturity in level. Maybe, I don't know.
Sorry, did you say high maturity material?
High maturity terrain zone.
Uh-huh.
So maybe some processes like erosion or I don't know what else just led to the same material.
Yeah. Well, remember, Mercury is an airless body. It's being hit by impacts all the time. So it's always having its surface destroyed and recreated and being mixed up all the time. So I think probably the older a surface on Mercury gets, the more confused its spectral signature will become. So I think when we were looking inside Rachmaninoff, we were looking at those smooth volcanic deposits that must be quite young. They must be some of the most recent things that have happened. And Nater Facula is young, and so it must, and it has a clear spectral signature. But the older surfaces in this map have mixed up signals. So I think it is to do with the age. I think that's probably one of the most important factors. Good. So that was Julia from Francesca's group.
Got interruption. Yeah.
So well, we've run out of time. I don't know if Francesca, do you want to continue? We haven't heard from every group, but maybe that's okay.